quadratic couldn't come, then we have talks. The talks will be 12 minutes. The talk and 3 minutes question. It's a compromise because previously it was 5 minutes talk and I wanted 3 minutes talk and 12 minutes questions. So the compromise is what I said. So I will present my view. It's not my view actually. Some points about binary system to take into account when today and tomorrow people will present binary system. So, what in the regime of binary shaping, peculiar planetary nebulae are really spherical planetary. They are really peculiar because they are rare and it's hard to find and they are boring. Okay. So, here it is. So let me, one point. If you take the angular momentum of the sun and let the sun lose mass on the AGB, this is the mass left in the envelope. It says envelope, not the total mass. So when you come and the envelope in the mass is this value, you can see 0.2 solar mass, the angular momentum of the envelope of the sun will be less than what the Earth has. So even if you swallow, I mean you are an AGB star, you swallow a planet, you have more angular momentum than you had before. I'm talking only a planet, just as an example. Keep in mind that some cases it can be a planet, but not Earth-like planet, like Jupiter planet. Okay, more. Yeah. Okay, comment on magnetic fields. This. So we had talked about the sun. So when we talk about magnetic field, there are different issues, and we should not be confused. So the sun has a global dipole field, yet there are locally strong magnetic fields, which are called magnetic clouds and so on. Now, B fields, magnetic fields, work in launching jets, yet I will call it jet shaping, not magnetic field shaping. So magnetic field only if in the AGB we have a magnetic field. So I will raise now 3 points. First of all, binary shaping is not an alternative or competing with magnetic shaping, magnetic in the AGB, or shaping by jets. Well, in the binary regime, you simply need the binary companion if you want magnetic field or if you want jets. I will not, pick what you want, but you need a binary companion. And tomorrow I will talk more about jets, but the companion is required. There is no way single star can do it. No way. It doesn't work. Yes. Second point. The common envelope we are looking for, in many cases, for short binary periods. In many cases, the companion will merge with the core. So you will have the AGB core, and you can have rapid rotation of the central star or the type of state. Rapid rotation of central star, equal cluster of 13, which also are described. There is an open question: what effect does this have on the shaping? You have a merger. What does it have? I'm not sure we know. No one of you will find the companion. You might have rapid rotation. The importance of companion core merger is in dispute. I think it is very important. It leads to very interesting objects and so on, even progenitor of some type 1a superworld. This second point. Third point, energy and angular momentum. We want energy and angular momentum for different reasons. So when we have the companion outside the AGB envelope, energy, real energy, can come only from a collision to the companion. Because you have also angular momentum, you form an accretion distance, a very high transfer rate, mass transfer rate, you are likely to form jets. In many cases, impulses on one event, like in Eta Carina and so on. Angular momentum, when the companion is outside, you can have tidal spin up of the AGB star, which you can build into magnetic activity, or you can have mass loss from the second Lagrangian point, which will lead to slow equatorial mass loss. In the common envelope, you have spiraling in, which by itself releases lots of energy, but only when the companion comes in. So in the common envelope, you deposit angular momentum outside and energy inside. It's very, I think it's a complicated process. Not getting to it now. So envelope ejection mostly in the equatorial plane, but not only. If you lead to merger, you release huge amount of energy, which, as I told you, I'm not sure. Let me summarize these points. Binary shaping is not against magnetic field jet, simply you need to combine. Merger microcore, and this is an interesting process we didn't study enough. Combine an outside AGB envelope, jets, and all mass documento and all tidal spin out, all these effects can be a common envelope projection mostly for the equator. If you have a common envelope, you can still have jets prior to the answer of the common envelope. Yes. Okay? So let me point accretion to a companion. It's a simple, if you want gravitation and energy to play a role in shaping, you want the accretion energy to the companion to be about equal to the energy of the nebula, this order of magnitude. So this is the energy of the nebula. Mass of the nebula times the velocity of the nebula squared, kinetic energy, which is about the mass of the nebula times this factor, which is the escape velocity squared, which is the escape velocity from the surface of the AGB star. And this you want to equate to the energy which is released, which is the mass accreted times the mass of the companion divided by the radius of the companion. This is constant. So if you put numbers, you take the AGB star to be 5 times the mass of the companion during the mass transfer, the companion 1 solar omega and the AGB 1 u, you need to accrete only 5%. So between 1 and 10% of the mass of the nebula, and you have enough energy to influence the shaping of the entire nebula. If you only want lobes, if you only want to influence the lobes, then you can even have less, 2% of the nebula. So this is very efficient, but how do you use its energy? To have accretion plus ejection, you need non-spherical flow, which we know from Young-Stern object, supermassive black hole, accreting neutron star, accreting black hole, and so on. You have an accretion disk plus jets. Jets are very efficient in shaping, much more than radiation. We'll talk about it tomorrow. So angular momentum source, we have several sources. Large enough specific angular momentum of accreted mass is required for the formation of an accretion disk. This is very important. So you can have it either for mass transfer, in the binary system we see it in characteristic variables and many other systems, or fallback onto the post-AGB star. This can work much better in a post-Thorne envelope evolution because you inject masses a little bit angular momentum. Say if you have Jupiter planet entering inside, maybe you have enough angular momentum to fall back material. So maybe some born-again planetary nebulae have fallback material with the central star. You have a planet or something which didn't shape much the envelope, but was enough for the fallback material. I don't know, it's speculation. Yeah. Okay. Most of the interactions that I listed above, like common envelope, strong tidal interaction, merger with the core, will not only shape the nebula, but will also cause the AGB star to lose all its envelope. Not necessarily, but in many cases. This will lead to a correlation between high massless weight, which terminates the AGB, and asymmetry, like bipolar structure, point symmetry, and so on. As well, many of the interactions that I listed here lead to departure from axis symmetry, which I mentioned to you before, and I think this is a very strong clue which people ignore. Okay, triple system. Last 2 points. Triple system. In many areas, for planets to bypass collision, it's now in the literature, you can see it a lot, just put Kozai mechanism. People describe the Kozai-Little mechanism. What you have 2 binary, 2 stars in a binary system, and another star here with an inclined orbit. The binary, inner binary have this orbital, and the third one have this orbit, and they perturb the system, can lead to collision, to migration, to form hot Jupiter with the central spin opposite to the orbital, and so on. Just look the literature. So I encourage young people, younger than just a number and choose for age, to start discussing such system. Look at triple system. Many of the binary actually, what Joe, you said something?
I still qualify, thank you.
You and 2 other here, okay? But take it. we should start looking to that. They will form some interesting planetary nebulae, not peculiar, because only spherical are peculiar. Last point, which I don't know if it's related to here, because there's universal bright end to the planetary nebula luminosity function. It's see in poster 30. This is a big puzzle. So maybe binary system can explain this, because we see in both young population and old population, we see the same bright edge of the luminosity function. Unless there are star formation episodes in elliptical galaxy later than what traditionally method teaches, because we look at elliptical galaxy, it's old population, but so we need to choose one of them. In the past I thought binary would explain it. Now I tend to think that people say old population or some recent, you know, 1 billion year ago, star formation episode, which you don't see in other indications. Maybe in the planetary nebulae, we do see hints of planetary. Albert mentioned it in a previous meeting in Spain, and Bruce Balik now mentioned that they see star formation episode between M31 and M33. I think we have some star formation episode. Either way, we have some very interesting indication here. Either we, with binary, can explain something very puzzling, or we can tell people who do galaxy and star formation, look, you are wrong. For planetary nebulae, we learn that there is star formation. So this is not related to asymmetrical planetary nebulae. We should keep an eye on this. So I think this is what I have to say, just point to remember. Also, you want to add. We have 1 minute for question. I know the answer to if somebody, I said something. Albert, you wanted to say something? Yeah.
Can I say something?
Yeah, we have 2 minutes. Yes, 2 minutes for question.
It seems to me, Noam, that maybe you're right, maybe you're wrong, but binaries can predict anything and never explain nothing.
Say it again. You have to quote.
In English this time?
But no, prediction and explanation are contradicting.
You can explain anything that I've never observed. And so what do you actually predict? That would like to know. Can binaries make a specific prediction that I can test? Or is it that everything that I can observe, you can explain with the binary?